defense in-depth engineering. This is kind of an interesting topic. Why are we talking about defense in depth? Aren't there bigger problems for us to be solving? This is interesting. As Jim pointed out in the keynote this morning, we're kind of at a new era of AppSec. We have static analysis tools that are solving a lot of our problems for us. But what types of things are not being solved by static analysis tools? What things are often overlooked by consulting firms? When I think of defense in depth, I think of controls that may often be overlooked. And folks are generally aware that security is an onion, and I hate using that terminology, but there's layers to it. So defense in depth is about having several different layers there. Now, it's easy to say everything is defense in depth, and in some ways that's effectively true. So 2021, OWASP introduced insecure design to the OWASP Top 10. In my opinion, that's a huge win. And I'm sure everyone's heard the buzz of shifting left. That's been a big term for me lately. And so when I started thinking about giving a talk on insecure design, the first thing I did was reach out to one of my colleagues who's a designer and say, hey, I'm giving a talk on design. Do you mind doing some stuff for me, some art? And so he introduced Scully Skate Shop. So there's going to be a little bit of relevance here. But clearly he had no idea I was talking about security design and not actual other graphic design and such. So the OWASP Top 10 insecure design is to focus on risks related to design process and to call for more use of things such as threat modeling, secure design patterns, and reference architectures. And this is where we're starting to see a lot of the industry shifting. In fact, there's talks here on threat modeling, there's trainings on threat modeling. I walked in at the end of the talk here and someone was talking about threat modeling as well. So everyone's talking about threat modeling. Hopefully folks are doing it. I'm not here to talk about threat modeling. So before we get too far, let me introduce myself. My name's John Poulin. I'm Forced Request or Forced_request, depending on where you look for me on the internet. I am a manager of product security engineering at GitHub. My team focuses on basically internal consulting, secure code review, a little bit of threat modeling, architecture design, things of that nature. So I like to say I manage a team who hacks things now. I'm not quite as technical as I was a few years ago. Before I moved to GitHub, I was a consultant. And there I spent a lot of time doing technical work, a lot of secure code review, a lot of pen testing. And even before that, I worked as a software engineer. And I like to make the joke that as a software engineer, I wrote things that were hacked. We know that's not true. None of my code was ever compromised, right? But now I wish that was the case. So yeah, I'm excited to give this talk. I've never given this talk before. It's something I've been thinking about a lot at work. So hopefully folks enjoy. And with any luck, there will be time for questions at the end. If not, catch me in the hallway. I know I'm standing between folks and lunch at 11:30, so pretty challenging spot to be in up here. The first thing I want to talk about, and there's kind of four main categories of this talk, and the first one is to design for incidents. I'm only talking about this because one of our incident responders at GitHub is sitting in the audience here, so I wanted to make sure that their work was included as well. So becoming friends with your incident response team, who here works on an incident response team at all? Okay, a few. Who here are engineers in some capacity or writing code? All right, more. So make sure you all are friends with your incident response teams. So when I think about engineering and I think about design, one of the first things that comes to my mind is to really understand the risk of your system. Most of the systems we're building are not for fun. There's actual business purposes. They're going to be handling certain types of data. So if I ask you, what's the riskiest type of data that your system is handling, are you able to tell me? Do you even know? Sometimes if you're working in a large company, you may not really know what types of data you're handling. So it's super important to have an understanding of what that is. As an engineer, this generally is stuff like billing information, PII, et cetera. Whatever your company considers sensitive, you should at least have a general understanding of that. But more importantly, make sure that is documented, right? If you are investigating some microservice that's hidden in the back corner of your data center, as an incident responder, you're going to want to know what type of data is intended to be flowing through that service, right? And if that's not documented somewhere, Suddenly you have to go find an owner of the system, you have to talk to them, hopefully they understand, and it really complicates the process. So a lot of this can be solved by having data dictionaries, well-defined data dictionaries, things of that nature. And then also making sure that as you're writing code, you're keeping an up-to-date data flow diagram or UML diagrams that are stored in accessible places. Super important. Okay. So build a plan of action. For those of us who work in smaller companies, there's a good chance you don't have an incident response team. So what's going to happen if your product or project is undergoing an active compromise, for instance? Who's going to be handling that? What are you going to do in those situations? If you do have an IR team, work with them to understand what the logging capabilities should be. What do you need from a telemetry perspective to know what's going on? What data should be logged? Do you want to be logging your most sensitive data, such as user addresses? That's another question. So working with the IR team can really help you understand what type of data should be logged so that you can have a successful incident response engagement. And then the other question that comes into play a lot, and maybe this doesn't necessarily fall into the engineering shoulders so much, but how long should those logs live? Do you have compliance requirements that dictate you need your logs to live for a year? Maybe it's 2 weeks. What happens if you keep your logs longer than that time period? Lots of things to consider. And so working with your IR team or your compliance team can really help you understand what those considerations need to look like. Understanding expectations during incident response. Incident response can be pretty sweaty. I'm glad that's not my job. Sorry, Alex. Hopefully I'm able to help you when you're doing it. This is stressful stuff, right? As engineers, sometimes we're brought into the war room and then we're sweaty because we're trying to help figure out what's going on. We're trying to help fix things. And then in the back of my mind, I'm always thinking about, okay, is there going to be public communication about this? Are we going to need to share this with the public? At GitHub, that happens, right? So super sweaty even with an IR team. And then if you're not fortunate enough to have an IR team, chances are you're going to be handling all this stuff yourself. So what can you do from an engineering perspective? You really need to take ownership. You need to fully understand your product and be aware of these potential gaps. And so I always recommend building playbooks to help out. Even with an IR team, you need to have playbooks. But if you are an engineer without an IR team available, playbooks are going to be even more important. Being prepared to own the outcome. When I talk about communication, public comms, I always come back to this particular incident. So this is from 2021, where GitHub started receiving reports that users were basically accessing other users' sessions. And this was a super difficult one to track down. I was lucky because I was on PTO during this. So, yeah. So I came back and I'm like, wow, what is going on here? So in this case, there was a rare security vulnerability. We talked about all this publicly. We fixed it. It took a lot of engineering talent to figure this out. And if I was in those shoes, I probably never would have figured this out. So I'm glad we have some really smart folks. And there were customers affected, and we weren't sure how many. So we said that. We came out and said that publicly. And we believe that transparency was really the important key there. So what we did is I don't know if anyone was aware of this, but we mass logged out everyone on github.com. So yeah, that was fun. And from what I understand, our clients and our customers were really appreciative of us being forthcoming with them and taking the proactive stance to just log everyone out because you might have been affected. Who knows? It was really hard to trace this one down. So be prepared to own the outcome. If you have to make decisions like this and it goes public, folks are going to start asking you questions. So think about that and see what you can do to treat your customers as best as possible. And remember, investigations, not necessarily incidents, but investigations are always going to happen. Investigations generally lead to incidents, and then incidents can, lead to breaches. It's a whole thing I had to learn about. But we do a lot of investigations at GitHub. I'm involved in a handful of those. Alex is involved in more of them. And at GitHub, we really value a blameless incident response process. This empowers the employees, the engineers, the product managers, by allowing them to continue delivering, the best products possible. If you have your engineers pinned into a corner asking them why they wrote code that was vulnerable, that's not going to be effective, not at all. So remember, everyone is on the same team here. And when we're in the hot and sweaty incident response process of the war room, just remember, use your plan of action that you've defined. Hopefully you have playbooks. This is a big one, and I think it's often overlooked. This is pretty big for us at GitHub, supporting customers. So keep in mind, your customers are going to have incidents too. Their authentication credentials are going to be compromised. Their laptops are going to be stolen. What can you do to support them in these situations? Now, at GitHub, one of the common scenarios here is they have lost their PAT, for instance, or some sort of authorization token has been disclosed. They will, launch investigations of their own. And so how can you support them in those? So customers are generally going to want to know what data was accessed, when was it accessed, was it modified, et cetera. And so you need to be able to help provide them with those answers when at all possible. And if you don't have the information they need to conduct their investigation, they're not going to be happy. And you're going to start losing customers over this type of scenario. So how can we go about providing this data to our customers? Self-service logs are a huge win. At GitHub, we have a feature called audit logging, which allows customers to go in and view events at a repository level, at a user level, at an org level. I don't think it's at a repository level, but I could be mistaken. And this is self-service. They can go in, they can help themselves, and see what actions have been taken against a particular actor, or a target, rather. Now, the flip side of this is, as soon as you provide a mechanism for self-servicing, you need to think about the data that's being surfaced there. Sanitization comes to mind. So if you're logging things like user IP addresses, should you be disclosing those to customers in a self-service manner? Probably not, right? But that's something you have to think about. You also want to make sure you're not disclosing credentials or tokens, things of that nature. So anything that you would consider business sensitive, you need to have sanitization in place. And then again, having dedicated playbooks for support goes a long way to help your support team provide customers with the information that they're looking for. And so I like to recommend auditing all the things, okay? And so here's some code. Hopefully it's readable on the back. I know the black can be a little hard to see, but ensure every state-changing request flowing through your application is auditable. So what do I mean by state-changing requests? Really anything that's creating, modifying, deleting, updating, whatever you want to say, anything that's changing data in the system should be able to be audited. There should be accountability for that. So in this particular code snippet, anyone here do Rails development? Or am I the only one? Yeah, I'm the only one. That's typical. I've spoken at Ruby conferences and been the only one who's a Rails developer. So anyways, what we're looking at here is what's effectively a base controller. So all of our controllers in the app inherit from an application controller. And then we have an after action, which calls a require trail audit function. So this after action says, after the HTTP request has been basically fully serviced, and we're about ready to send it back through the web server to the user, we're going to run this particular require audit trail function. And then in that function, we look and see if the HTTP request method was anything other than a GET or a head request. We're then going to look and see if the request was audited. If it wasn't audited, what we're going to do is raise an exception and say, look, there was some state-changing request here that was not audited. This is a problem because there's no accountability for it. This is not the best code example. Does anyone see why this may not be the best situation here? Of course, no Rails developers. So the cause for concern here is that we are raising an exception after all of the logic has already been processed, right? So that's not doing much. So a better situation would be if we instead emitted an audit log entry that said, hey, this wasn't audited. And then we can have accountability for those. We can review that. So this is just a general idea of using some middleware to capture HTTP requests that have not been audited and surface those. This shouldn't necessarily interfere with the end user behavior, but it should be a metric that engineers and folks are looking at to understand where there's a lack of coverage in their application. All right, let me grab a quick drink here. Just water, don't worry. So where do we go from there? I mean, we talked a little bit about incident response. Preventing regression is what we're going to talk about next. So the goal with incident response is never to waste a good incident. So how do we prevent regression? So if folks aren't aware of what I mean by regression, what I mean is effectively ensuring that we don't have the same situation happen again. And so the first thing we want to look at is ensuring that during our IR scenario, we do sufficient root cause analysis to really understand the vulnerability itself or the bug and use that to drive our solutioning. So we want to fix things at a code level. We don't want to rely on third-party products, things like WAFs to solve the issue. So make sure you have an understanding of the actual issue itself, and then perform thorough variant analysis. So when I say variant analysis, we've identified the root cause of one particular issue. Do we have that same issue in other places in our code base, in our services? So variant analysis is super useful there. If folks here are GitHub Advanced Security customers, we have a multi-repo variant analysis tool, which is pretty cool. I don't use it myself, but we have teams that do rely on that, and pretty cool feature. And again, this section's all about not wasting a valuable incident. So variant analysis is super valuable. And then most importantly, utilize tests to prevent regression. Who here has security tests in their products that they're aware of? I saw a lot more engineers than I saw folks raise their hands for that, so that's a bit scary. I'm not going to ask you which products you have. All right, who's ready for a test? All right, that's all I mean. I'm not actually going to ask you all questions. Sorry if this is a bit hard to see, especially in the back, but effectively what we have here is an integration test from OWASP Rails Go, intentionally vulnerable Ruby on Rails app. And this particular test is, actually, does anyone have any thoughts on what we're testing for before I spoil things? It's file upload, yeah. So we are testing, and I think I heard someone say it, but you're being too modest. Command injection, right? So if you look on line 21, basically we have a payload to test for command injection. So this is the type of payload you would see, someone from a consulting company using to demonstrate, exploitability. And so what we do is we create a legitimate file, we put it on the server somewhere, and then we have a payload that basically attempts to delete the files from that same directory. And if it's successful, so on line 30, in an ideal world, if our application is not vulnerable, that legitimate file we initially created will still be there, meaning it hasn't been erased because our payload has not executed successfully. So yeah, this is a bit of a confusing test suite because you all aren't Rails developers. You're probably not too familiar with Capybara. There's a lot going on. But the idea is that our goal is to try to delete a file, and if that file is not deleted, then we have theoretically mitigated the security vulnerability. Does anyone see any potential improvements? Any ways we could write this test a little better?
You mean besides not using Rails?
Okay, Rails aside, Rails aside, you must be a .NET developer. So I have some recommendations for this particular test. So first of all, it's great to have a test to begin with. First of all, I always recommend using unit testing whenever possible. What we looked at before was an integration test. A lot of things can change between entry point to the application and where the actual logic is being executed. So when possible, use unit tests instead of integration tests. Consider alternative payloads. So my big pet peeve with this test is that our payload is trying to delete data. That's a pretty serious cause for concern, because if we delete our data, is our test suite going to restore that data that was already there? Or are we going to end up in some situation where we suddenly have flaky tests? So removing data is not effective. There are better options, such as just trying to execute sleep. You know, if your test is taking 5 seconds to respond, you're probably still vulnerable if you just told if you gave a payload to sleep for 5 seconds. So definitely not a fan of the RMRF. What about alternative encodings? So how will things differ if the data provided was URL encoded, maybe base 64 encoded, maybe had Unicode variants? And after all, what is the happy path? What is the expectation if someone uploads a file that appears to be potentially malicious? We don't cover that. We verify that our files have not been deleted, but what happened to the file that was uploaded? Because there could have been legitimate files with some of those characters in the names. What happened to those? And then false negatives. In this case, race conditions come to my mind as well. So maybe the test runs concurrently, and some of the other tests rely on those files as well. So a lot of potential issues there. So one more test I want to talk about. The goal of this test, and this is from Mastodon, open source social network. I don't use it myself, but if you do, they have security tests, so that's good. The goal of this appears to me, at least, to be testing for some variant of cross-site scripting. So we're making sure things are stripping JavaScript tags, and below we're making sure things strip malicious classes. Not sure what a malicious class is. So what can we say about this test? What would change if the input was normalized in some way? So the first thing that struck me as weird is we have a capital H in the alert. Okay, that seems to be non-standard. But what if the application was designed to run like 2 lowercase on everything? We may still be vulnerable, but because we're looking for a case-sensitive string, it may be a false negative there. Are there tests for other attributes? So I'm not sure how well folks are familiar with cross-site scripting, but a big vector there is attribute injection. And so we see a test for malicious classes, but we don't see any further tests. So what about malicious IDs, first of all? What even are malicious classes? I have no clue what Mastodon means by a malicious class. So yeah, what are the legitimate classes? I mean, I guess mention is a legitimate class, but there's a lot of context left out in this situation. So here's some advice for designing tests. First of all, make sure you're using tests, integration tests, unit tests, whatever works. If your company is not using tests at all, it would be a huge win just to have some testing framework in place in general. And make it part of your CI/CD process. Focus your test case on a specific issue, such as integration tests. So if someone reported a cross-site scripting vulnerability in a user profile, it makes sense to have an integration test that tries to set a user profile to have a JavaScript code snippet and validate that after you fixed it, that's no longer rendering. And then from there, we can look at our variant analysis and say, okay, we've encountered these other scenarios that seem to be vulnerable. What can we do to make this one cross-site scripting test we just wrote more extensible so we can use it in other places in our application? I already talked about this a little bit, but test as close to the logic as possible. So if you have, I don't know, a blockchain app and you're transferring money around, Probably shouldn't be able to transfer if you have a negative balance, right? So that's an area where you'd want to make sure you had unit tests in place to test for those lower level comparison operations. And then a fun one I like to touch on, focus on testing for permutations. And I'm not sure if folks know what I mean by that. So permutations are effectively a reusable way to test for variance of payloads. So we talked a little bit about encoding concerns, right? So why not have a function that will generate variants or permutations of the input? So in the example here, we take the input, we look at the base 64 encoded, we look at the URL encoded, URL decoded. You can do as much as you want here. And then you just want to design a test case that looks for any of those permutations. And if any of those were found, you probably have an issue. This is a super easy win to get better test coverage. And this is something you should be using as both input to tests and also output of tests. So if you're looking to see if your HTTP response includes something, look and see if it includes the permutations of that thing at all. Pretty easy win. So shifting away from that a little bit, designing for extensibility. It's super important to recognize that your product is going to change. Your company is going to scale. Things are going to be different. All right. Who here sees the problem with this? Shouldn't be very obvious, right? So, and no one's hollering at me. That's surprising. So how would we fix that? Okay, use parameterized queries. This is kind of SQL injection 101, where we have some user input concatenated with a SQL query. The way we recommend solving this as an industry is using parameterized queries, right? Does anyone disagree? Okay, good. What's the solution here? What's the problem? How do we fix this? We're getting close to lunch, so folks are quieting down now. Parameterized queries will not work in that situation. So if we look back at it, what we see here is we're using user input to determine which database table we want to select from. And parameterized queries can't be used to mitigate the risk in this case. And that's because most database management systems do not support parameterizing certain fields, one of which is the table name. So you will not be able to parameterize that. Generally speaking, there's some exceptions to that. So an alternative approach is allow listing a set of known table names. This might seem a bit like a contrived example, but if you ever work in any sort of company that has like a dynamic reporting engine or its own custom SQL interface, this is a huge thing. So what's the solution here? Utilizing a framework control or middleware to introspect the parameters. Okay, so walking you through this code, this is a solution. So we're using a before filter that says, before we run the code here, we're going to run this before filter function, which is called require valid table. And so we look to see if a list of the valid tables we've provided includes the user parameter, meaning is a user trying to access a table which we want to give them access to? And then if not, we're going to raise an exception and say invalid table. Choose your own exception name. This is just my contrived example here. And so this works by ensuring that the user is selecting from a table that we want them to be able to select from. There are better approaches here. So one better approach, which I'll show you, looks more like this. So we have a before filter now called set table. And this particular method looks to see, again, if the user input is a valid table. If not, it raises an exception. That's not much different. What is different, though, is we're referencing, or we're setting a value called current table, and we're setting that to the user provided value. And then on line 6, we're now referencing that new current table variable. And so the idea here is that we have defined this current table variable to be something that is trusted, and we know it will only exist if we've gone through that before filter. So that's kind of the minor nuance there. So in this particular example, If someone were to comment out that before filter, suddenly you have SQL injection again. In this example, if someone comments out the before filter, you're going to have a function that doesn't work because there's an undefined variable. This is a defense in depth measure. I don't know what I'm saying anymore. So accept the reality. We're going to write insecure code. You can have the most thorough secure coding requirements document in the world. Folks are going to write insecure code. So it's important to understand that, accept that, and then build an exception process for that. One thing I like to recommend folks do is annotate insecure code. So in the example there, we have code that's potentially vulnerable to mass assignment. If you run Brakeman or any Ruby static analysis, it's going to report that. So if our developers choose to accept that risk for some reason, maybe there's other mitigating controls, having a simple annotation in there will tell us this is an insecure design principle. We shouldn't be doing this. And I would recommend also linking back to some discussion or some exception, because this will reduce the risk of someone copying this code and using it somewhere else in the application. It also provides us the ability to document and audit for these insecure code patterns. So for example, in Rails, I can run rake tasks. I can look at all of my insecure tasks and then audit those, see if that's something I want to revisit. I've only seen like 1 or 2 clients ever using patterns to annotate, insecure code. So this, I think, is a pretty easy win. And then building, uh-oh.
Just give it your files.
I'll just turn my laptop around. Good time for a water break.
Just to give some time, maybe one comment or question. How do you detect malicious additions or deletions on that insecure annotation? Maybe it's good to have like some sort of listener.
So I was having a hard time hearing you, especially with the door closing, but were you asking about how we audit those?
Yeah, how do you detect new instances of that insecure annotation happening? So let's say you want to prevent some developer to maliciously, removing or adding one of those annotations.
Yeah, good question. So, and this probably isn't the best possible example, but if you use linters and you have test suites, you can keep track of the count of how many of those annotations there are, and then basically manually. Okay, thank you. So you can use linters and basically say, okay, this count of insecure code annotations increased or decreased. Can you provide, an explanation for that? Cool, back in business, thank you. I let my wife use my dongle a year ago when I stopped kind of traveling, and here we are. This is someone else's, and now I've got a secondary backup. So, and we're getting kind of close on time here. So building paved paths for extensibility. This is a favorite of mine, or I should say a security questionnaire favorite. We get this a lot at GitHub, security headers. Okay, I don't know if anyone knows where I'm going with this, but security headers, and this is kind of a bold statement, but in my opinion, security headers are effectively the new bank rate encryption. Everyone wants to see it, and they want to see it because it's visible to them. So, for example, if I go to the lastcon.org website, I don't know if they're vulnerable to cross-site scripting. I don't know if they're vulnerable to SQL injection without testing. Security headers, I can load up, I'm not going to throw any names out there, but a dynamic website to scan your security headers and get a report card on it. Everyone can do this. And it's not a bad thing, but I think there's too much emphasis on security headers. So one in particular I want to talk about is content security policy. In this header, I do find a sufficient value. So content security policy, if you're not aware, is a newish directive that browsers will process to understand which types of data your application can load, where it can load those from, etc. There's a lot to it. Now, CSP version 3 is coming out as well. So there's a whole lot to talk about. Now, with CSP, the main win here is that it's a huge help in reducing the cross-site scripting vulnerability, or at least reducing the risk of them. And so we'll talk about that more in a few minutes. But the reason we're even talking about CSP today is because it's easiest to roll out early in the app lifecycle. It's a lot harder to roll out a content security policy in an already mature app. And there's report-only mode and things that you can do to make it a little bit more smooth. But I recommend starting with a default source of self and then adding exceptions, which is what this section of the talk is talking about, as needed. And the two main directives I generally am concerned with is a script source and then the connect source. And I'm not going to get into much detail about those. So with security headers, what I normally see is folks looking at your domain and evaluating the security headers. What a lot of folks don't realize is some headers, CSP as an example, can be set on a per page basis. So looking at the headers across the entire domain is not super useful. So what we see a lot of at GitHub is cases where folks want to run A/B tests with like different vendors, different third-party JavaScript. Never makes me feel good when someone says third-party JavaScript, but that's what the business needs. So CSP is one of those headers that can be set per page. So my recommendation here is to utilize one strong site-wide policy that is secure and then allow exceptions on a per page basis. So as you or other engineers are seeking to connect to different sources, pull in assets from various locations, they can do so for those particular pages. And I'll give you an example of what this looks like. But what this does is allows us to have a very tight global policy and then have exceptions at a page level. That way the risk is reduced to a specific page or a specific set of pages. At GitHub, we use the secure headers library, which we also maintain. This makes it super easy. For all you Rails developers, you should check that out.
What if you have a single page app?
That's a good question, and we can talk about that after, but your single page app is probably communicating with an API somewhere, right? So there's two sets of concerns in that situation, but you can use the HTTP meta tag, but I'm not sure how that works in per page apps. So I want to give you a clear example of what I'm talking about here. That's a joke, because clearly this is not clear at all. But if you go to github.com/readme, you see a content security policy which differs from my profile on github.com. And the README project is an area where we allow users to provide videos to talk about their projects and stuff. And so we made the decision that we're okay sourcing from these particular domains on this page, but we don't want all of github.com to be exposed to ctfassets.net. As much as I'd love to trust ctfassets.net, I really don't even know who they are. So this is an example of where we have reduced the risk across github.com and allowed our product team to do the work they needed to in a particular page. Is anyone doing CSP on a per page level? You are? Okay. Good. All right. So CSP. This leads us to cross-site scripting. Edge cases and XSS. So CSP, which we just spent the last 5 or 10 minutes talking about, is really, in my opinion, only for defense in depth. If this is your primary mitigation strategy for cross-site scripting, it's not sufficient. In fact, if you look at the Mozilla documentation, they clearly say CSP is an added layer of security, right? So in so few words, that's saying a lot right there. So use CSP, spend the time to have a well-defined policy with exceptions. Don't rely on it. Output encoding is still key. I would say these days, most of the frameworks I look at do output encoding by default. Rails certainly does. And the largest concern I normally have these days is with exceptions or exemptions from that default output encoding. So in Rails, for instance, and I guess next year I'll come with a different example. Golang maybe? I don't know. So in Rails, for instance, if you call the .html safe, what that does is say, we trust this as HTML, and we want to allow it to be rendered. So if you see HTML safe, there's user input, it's probably going to be cross-site scripting. And that's because we've opted out of Rails default protection mechanisms. More issues than that, but the next thing I want to talk about is attribute injection. Towards the last couple of years of my consulting career, attribute injection was extremely common. And this is, I would say, the majority of the cross-site scripting vulnerabilities we reported. An attribute injection is when you're able to inject user input into an attribute of a tag. And so one of the main issues here is many web application firewalls look for brackets in particular. If you're a .NET developer, you may be familiar with request validator. Request validator looks specifically for a bracket followed by an alphabetic character. Attribute injection payloads would not have that. So they'll bypass request validator. They'll bypass a lot of the WAFs out there. And that's a big problem. And even more so, unquoted attributes. So if you're rendering user input inside a tag without quoted attributes, there's a cross-site scripting vulnerability right there. And that's because a user can enter some data with a space to inject a new attribute, and then suddenly your page is a bit out of control. So input validation, super helpful, but again, that's defense in depth. When we can do input validation, we certainly should be doing it, but that's easier said than done. And it doesn't always solve the problem here. So what if we want to allow users to have some HTML tags? What if we want them to provide a bold tag, for instance? Or what if we want a WYSIWYG editor where they can, update their profile, have some tags? Anytime I see something like this, that's my reaction. Okay, seriously though, I don't think I've ever been on a vulnerability assessment or pen test, encountered one of these, and not found cross-site scripting in some variant. If you're allowing users to provide a set of HTML, there's probably going to be a problem there. So how do we solve this? If your business requirement is, we want users to be able to provide HTML, how do you do that securely? So this goes back to our exceptions process. So in our secure coding policies that we all have, we say use output encoding. That's not going to work in this case because we want them to provide HTML. GitHub.com, we allow users to provide HTML. We allow users to provide Markdown, which is converted to HTML. So this is a problem I deal with every single day. And developers, by default, are going to opt out of the framework mitigation. So we're going to use HTML safe because that's going to make things work by default. But then we're going to have cross-site scripting. So the key here really is to focus on your plan. Take a step back and think about what tags do our users need to be able to use? Do they need a bold tag? Do they need to be able to provide links? Do they need to provide JavaScript tags? Probably not on that one. But important part is having a plan and understanding what exactly you want them to provide. Next thing, identify a list of attributes that need to be supported. These attributes are things like an href. If you want a user to provide a link, they probably need to be able to provide the href attribute. And then probably a bit less important now, understand the context in which the tags will be rendered. If they're going to be used in JavaScript scenario, you have to handle things a bit differently than if they're outputted into HTML itself. So the real solution is utilize a trusted sanitizer. And if I came here and said this 10 years ago, I probably would have been laughed off the stage because sanitizers have some bad connotations there. But the real emphasis here is spending the time to understand the library. DOM Purify. Does anyone use DOM Purify? Like 2 people. That is absolutely terrifying to me. DOM Purify is a sanitizer written in JavaScript, super prevalent on Angular apps, React apps, etc. And on their official README, they say it's easy. You just source it in and then call dompurify.sanitize. Super easy. And then you'll have clean output and you can work with that. Okay, so I give that a huge thumbs down. That is not good advice. It's never that easy, is it? And this goes back to knowing your libraries. So if you look at the screenshot from the README, they say that Note that by default, we permit HTML, SVG, and MathML. Okay, what does that even mean? I mean, we're talking about allowing users to provide a set of HTML. Do we want them to provide SVGs? What's the risk there? What even is MathML? Well, I know, but only because of incident response and stuff. But yeah, we know about MathML. And their recommendation is to use profiles, right, that indicate we only want to render HTML. That's great, but that's not what they said when they told us it was easy to use. So that's a pretty big problem. And by the way, not picking on the DOM Purify folks, they have a very well-maintained repository. When I looked probably about a week ago, they had no open issues, no open PRs. They're actively resolving bugs, vulnerabilities, et cetera. So huge props to the Cure 53 folks on that. So what is the default behavior? What HTML tags will be rendered as HTML? What will be removed? Will they be encoded? There's a lot of questions. They say it's easy to use the library, but I don't understand what the outcome is going to be. So, oh, typo, bad on me. The answer here is roughly 110 tags will be outputted. That is, they will not be removed, they will not be encoded. 110 HTML tags will pass through those filters. What are those? Well, you're free to go look. But in order to understand the risk posed to your application, you have to understand what those tags are. Are attributes supported? What is that story? Yeah, by default, they'll allow you to render over 100 different attributes. Okay, so what's the risk there? And DOM Purify uses an allow list approach where you can explicitly deny certain attributes. So if you had a business requirement that said, like, hey, they have a great source of tags or attributes, but we don't want our users to be able to provide one of these, yeah, you can deny list it. Seems fine, right? So if we look at this particular example, anyone want to take a stab at the expectation here? So we have some payload, which we've hard-coded. It's a link with a class and a data URL attribute called DOM Purify, and then we just drop it into the DOM through inner HTML. So how is that going to render? Anyone have any thoughts?
Will it strip out data URL?
That's a good question. That's exactly how it's going to render. It does not strip out data URL. It does not strip out the class or the href. So that entire payload is going to be rendered as is. And so there could be some concerns here. So the major takeaway is that using DOM Purify with default settings will allow us to inject classes, which we just saw. It'll allow us to inject data attributes, which we just saw. I didn't show you, but you can inject IDs as well. That's one of the 100 permitted attributes and more. Again, 100 attributes, 100 tags. There's a lot going on that DOM Purify allows by default. What about event handlers? I mean, this is the day of the modern web. Like, we are doing a lot of things in JavaScript that are relying on the DOM. So what does that scenario look like? So if we take a quick look at this, in the top screenshot, we have a very basic, HTML. It's not even a form; it's just some basic HTML, right? With an event trigger. And so the JavaScript below looks for the payload we've provided. It sanitizes it and then injects it to the sandbox. All right. And so from there, we have some other logic which may not be totally clear. And you guys can't even read the line number, but line 15 down there, we see another .innerHTML, which is obviously a huge flag. So we're communicating with some API based on the data provided from the item ID. This could be pretty risky. Anytime you see innerHTML, you definitely want to evaluate that. So the last line here, which I am super sorry because I know you can't see that in the back, is a payload with, it's a div tag with a class of find reviews. We specify the data attribute with another typo there. And so that'll get injected to the page. None of that will be stripped out. And so what we'll have is we'll then have an injected class into our DOM, which is then able to be used to trigger other functionality. So in this case, it's going to initiate the show reviews mechanism, make an API call, and then render the response from that API as HTML. So you can't see the entire risk here, but what we're demonstrating is that our sanitizer is allowing the user to take full control of the DOM by using event handlers. So, and I know, I'm not even gonna ask, I know you folks, because I know I don't know all of the event handlers or observables in my application. So there's a huge attack surface here waiting to be exploited. And the worst part of all this, and kind of circling back to the beginning, is DOM cross-site scripting is nearly impossible to investigate because all the events happen in the DOM. They're never sent to the server. So our incident response team, such as Alex, is never going to know conclusively if someone was compromised through this. So this is something that we really need to address. And that goes back to really making sure you understand your libraries because the default's generally not sufficient. So key takeaways. Incidents happen. Definitely want to design in a way that allows you to improve the incident response scenario. Work with your incident responders, understand what data they want to see logged, understand what they don't want to see logged. There's a lot more to it than that. So prevent regression. If you're not using tests in CI/CD, that's a huge problem. If you're not using security-specific tests, that's another problem. So don't waste the incidents. Turn those into test case, expand your test coverage, use permutations to test for other variants. There's no reason your application couldn't have a permutation set of like SQL injection payloads, for instance. It's a pretty easy win. And when we work with consulting firms who provide proof of concepts, take their proof of concepts and put them into your test suite. Support extension exemption. Exceptions are going to be needed. So, make sure that folks have a clear path to request exceptions. Make sure the security team is supportive of folks deviating from the paved paths when necessary. Just make sure to have a conversation for it. Make sure it's auditable. Make sure you can hold folks accountable for it and just continuously iterate to improve. And then most importantly to me is understand your libraries. Everything we do these days is built on third-party code. We only understand a fraction of the surface in that third-party code. So understand the security critical requirements there. If you use a sanitizer, understand what the default behaviors are. So with that, if there's any questions, happy to try to take those. It's also, I think lunch is probably here too, so. Yes?
You mentioned DOM Purify has allow and deny options.
Yeah.
Are you able to create custom profiles as well?
You can create custom profiles. They even have what they call hooks. So let's say you want to allow a subset of an attribute. So like classes that are prefixed with like GitHub hyphen. You can do that by having a hook that says only allow classes that meet this regular expression. So pretty extensible from that perspective. Yeah. Yes?
When you're documenting data classifications in your application, how do you make sure that doesn't get stale?
Good question. This is more of like a compliance side thing. So if you have a compliance team, work with them to understand what that looks like. Chances are they have a place where that stuff should live already. I've seen folks go as far as like annotating it at the method level in the code. For instance, when you're writing like your Java doc and you have like your parameters, you could have a classification right there. And then you could use, unit testing to verify that any parameter has a classification with it. A lot of things you can do. It's really whatever fits best with your team's development practices. Any other questions?
Would your CSP mitigate injection tests?
That depends on the situation, but most likely not. No. So and we can talk about this more when we're not being recorded, but there are definitely scenarios like that where like you can inject an attribute which the CSP won't prevent, which will trigger an observer, and suddenly anything your observer is capable of doing will be evaluated. So some pretty nasty edge cases in that area. Anyone else? All right, I think that's it. Hey, they're clapping for me. That was timely.